There we go. And we're back live. Excellent. So first and foremost, and I'll remind you guys of this at the end of the class period, of course, but on Thursday, we are taking the benchmark assessment. I wanted to talk just very briefly about how just ridiculous it is that we're taking this benchmark assessment. Oh my goodness. I want to get on a little soapbox. So first of all, the benchmark assessment is made by that company, Linkit. And they have like 30 some odd questions for you to do in 60 minutes, right? 30 some odd questions in 60 minutes translates to less than 2 minutes per problem, right? Less than 2 minutes per problem. I teach AP statistics. In AP statistics, on the AP test, they have 90 minutes to get done 40 multiple choice questions, which means they have more than 2 minutes per problem. So what does that say? I don't know. I just found it very interesting. But yeah, on Thursday when we come in, we will have to get set up as soon as humanly possible, especially for those in the live stream. We will have to get set up as soon as humanly possible to get this benchmark started as soon as humanly possible. And you will have the class period to kind of get that thing done. The benchmark does not count against your grade, which is ridiculous. Why people in the higher ups are using these scores as like metrics for determining like how good or bad a teacher is doing at their job. It's like they don't count. If they don't count, you have kids who don't care, for the lack of a better term. Yeah. As much as we're like, come on, guys, put forth your...
I ran out of time.
Yeah.
There was like, it was in English, and there was like 7 different articles.
Yep.
I was like, I don't have enough time to read all this.
Yep.
And by the end of the class, I was like, I can only give you 5. And everyone was like, all right, I guess I'm just going to half-ass it. I just put the 10 answers.
I know. It's a ridiculous thing. It's just basically like, They want to know, okay, how are we doing? How are our students doing? We want to make sure that we're getting our scores going up. We want to make sure that our teachers are doing their job. It's just like they are putting so much emphasis on the data that is collected from these benchmarks this year, more so than previous years. And I'm thinking to myself, why are you putting so much emphasis on the benchmarks this year during a pandemic? I don't know. But, so we're taking our benchmark on Thursday. Okay, I can see your excited faces. Good? Why should she tell me to shush?
Someone's listening to music. Who's bopping?
Yeah. I can hear all of your music. Anyway. But yeah, we're taking that on Thursday. So, be ready, be ready, be ready. Furthermore, you had a major assessment due for me on Saturday. I inputted those scores, so you could probably see them on Genesis. I got the return thing on Google Classroom. If you did not take it, I need you to take it. It is now late and will be graded accordingly as late. So if you did not do it, that Edulastic assessment is still technically open. So make sure that you're getting that thing done. Projects. I got the vast majority, not all of them, but I got the vast majority of your projects done. Okay, make sure you submit it. I'm talking to people in the chat now. Make sure you submit it on Google Classroom. But I got the vast majority of the projects graded and returned with comments and whatnot. So everything looks to be on the up and up. We're getting there. We are getting there. The marking period ends on when? Thursday. But even though the marking period ends on Thursday, grades are not due for teachers until the 15th. Some teachers are doing a hard cutoff on Thursday the 1st. Some teachers are doing a soft cutoff on Thursday the 1st. I'm just going to let you know, as long as you give me ample time and I can give you something rather than nothing, I would like you to try and improve your grade. Just giving you that heads up. Speaking of which, hopefully you saw the post that I made on Google Classroom yesterday. Couple respond. All right. Wait, say what now? Okay, what was the first thing you said?
Yeah, what did you say? Cheeks?
Wow. No, I would give the benefit of the doubt. Like if I'm going to make this up, let's just say your lowest quiz grade or minor grade was an 80. And on this particular quizzes, you got like, a 75. I'll keep it an 80. This is mainly for like, there's a bunch of people who they have a 0 in for something. So it's like, oh, I got a 50 on the quizzes. Okay. He's better than a 0. You know what I'm saying? But yeah, you do have 2 attempts at that, and I will replace the lowest grade. Yeah. It depends on where the first decimal is, the decimal point, the 10th place. So, for example, 65 is passing. If you get 64.4, it rounds down. On the quizzes?
No, like overall grade.
Oh yeah, then it'll round up to an 87.
Okay.
Yeah.
So it'll just be like, say like I think 89.
It would round up. Yeah.
Okay.
Yeah. Question.
So we're not taking everybody from today?
Thursday. The math benchmarks were scheduled to be taken Wednesday, Thursday. Yes, and I need it to be taken. As I've done in the past, it's just basically like, if we knock it out and obviously we put forth the effort to get it done, and we're not just clicking through as I've seen people do in the past, then, yay, happy days, high fives, everything will be done accordingly. We'll get that thing done. Anywho's, as for today, I would like to continue with what we started the other day on Friday. On Friday, we started with a reintroduction to factoring. Now, today, we are going to take that reintroduction to factoring. We're going to take it a little bit farther, and we're going to slowly dip our toes into the beginnings of this brand new chapter. It's going to be nice, mainly for me, not for you. So, what I'm going to suggest, now I have some practice problems that I am going to post to the Google Classroom for those of you that are in the live chat. I have some practice problems. Now, if you would like to see those practice problems instead of seeing what I write on the board, then yeah, you could check the Google Classroom yourself and see that PDF. Absolutely, yes, you can. Otherwise, in the meantime, if you do not already have them out, I'm going to need those notebooks out and open.
Maybe yeah. Like a word counter for how many times you said that this year.
You're going to miss it one day. Just saying. For those of you in the chat, if you have not left a comment, please make sure that you do so I can check it later. That'd be fantastic. And I will post that PDF where it belongs. Let's see. Add, file, browse, skills practice, boom. PDF for today. Post. Chapow. There it is. So again, like I said, for those of you in the live chat, the PDF is now available to you so that you can see exactly what we're working on. I will be working, I'll be jumping back and forth actually. So I'm going to open this thing up in Lumen PDF. See what we got here. Okay. Come on, Lumen PDF. There we go. Almost. Because this thing just wants to be difficult. Today is the 30th. I'll zoom out. There we go. And we're going to call this simplifying rationals. Real quick, we got work to do. We're going to call this simplifying rationals. Now, some kind of a basic problem that applies to what we did the other day you may have a problem that looks like this. I'm copying down number 7. And then we can talk about what the heck it is that we are to do with it. I am copying down number 7. Now, we can do a lot of things with this problem, but let me tell you about one thing that you cannot do. One thing that you absolutely cannot do. You cannot just cancel out the 3a squareds. Ms. Markey, why not? Whatever's on top, whatever's on bottom, they cancel each other out. It's the same thing. Sorry, that's not how these things work. The reason is because of an assumed set of parentheses around the top and bottom of this fraction. You don't see it because it's not written, but you have to assume that they are there. You have to assume that there are, and I'm going to erase this, obviously, but you have to assume a set of parentheses around the top and bottom of the fraction. And according to the order of operations, you are to evaluate what is inside of parentheses before you take care of division. Now, it would be a different story if things were just all multiplication division. If it was all multiplication division, then we'd have a different story. But no, because of the addition subtraction, I cannot just cancel these two out. I cannot just take 24 divided by 12 and make that a 2 and cancel out the a's at the end. I can't do that. So instead, your job is to factor. You are to factor with every fiber of your being. You are to factor to see what could potentially, eventually cancel out. So I'm going to look at the top of this fraction. Oh, no, you got to keep that thing up, though. You okay? Yeah. I got you. You have to look at the top of the fraction by itself as a single equation and ask yourself, okay, well, if I have to factor, what's the greatest common factor? Can I take something out of those two terms on the top of the fraction? Definitely a 3a. They both have a 3 in common. They definitely both have a 3 in common in the 3 and 24. And they both have that variable of a in common. So I can take that 3a and I can factor it out by dividing both of those top two terms by 3a. Right here in the 3a squared, if I divide by 3a, I'm simply left with an a. And over here, if I divide, someone get the door. If I divide by 3a right here, I get minus 8. This is something that we absolutely have to do with these problems. This is something that we absolutely have to do. We have to factor. The first step of factoring is always going to be GCF. Take out that greatest common factor. Now, after you take out the greatest common factor, there are possibilities of factoring farther, but right here, this is linear. So I'm actually pretty good right here. On the bottom, oh, look at that. What's the GCF on the bottom for these two terms? 3a, that's a coincidence. If I take out a 3a, divide this by 3a, and I get a. Divide this by 3a, and I get plus 4. Now we got a different ball game. Now we have a different ball game. See, because here you have to assume parentheses. You have to assume that, well, this 3a squared is minus 24a. That plus or minus and that plus or minus, that doesn't allow me to cancel things out the way that I want. I cannot cancel out the things the way that I want if there's adding and subtracting in the middle of them. But this 3a and this 3a, the only thing separating them from the rest of the problem is division and multiplication. If I just look at this 3a versus this 3a, the only thing separating them from the rest of the problem is multiplication and division. And if you get to a scenario where that's the only thing preventing you, or not preventing you, but separating you from the rest of the problem, then yes, by all means, they cancel each other out. Absolutely yes. But you couldn't do it over here because of the addition, subtraction, separating things. You could do it over here. What's left over is an a minus 8 and an a plus 4. Nothing else will cancel. Nothing. Nothing else will cancel. You might, well, Ms. Markey, the a's. Nope, sorry. Addition, subtraction is separating them from the rest of the problem. What about the 8 and the 4? Sorry, can't do it. Addition, subtraction. This is the simplified answer. That's all you can do to the problem. Nothing more. Simplifying rationals will come down to two things: factoring and realizing when things cancel out. Those are the only two things that it'll come down to: factoring and realizing when things cancel out. Let's try another one. Now, my goal is this. I want to go over a couple of problems with you, probably two more. And then I want to give you an opportunity to knock out a few of these on your own, to see how well you can do with your factoring skills combined with this idea of canceling things out. The next problem I want to try is actually number 1. The next problem I want to try is actually number 1. So I'm writing that down, and then I'll flip my camera over. Again, if you do have the PDF on the computer, it's a bit easier to see, but there it is right there. Now, one thing I will ask all of you. What is separating every term from the rest of the problem? Or, yeah. What is not in the problem whatsoever? That's a good thing. On the first problem I showed you, the addition subtraction is what is preventing you from actually just canceling terms out the way that you want. But down here, it's like, oh, there's no addition subtraction. That means I can simplify the way that I want? Yes, absolutely yes. So let's actually figure this junk out. Now, here's the thing. I'm going to do it the long way. I am going to do it the long way. There are shorter ways, and I'm going to show you a shortcut in a moment after I do the problem the first time. But I'm going to do it the long way first. Like I said, I will absolutely show you a shortcut in just a moment. But I want to do it the long way here first. If you notice on the top of the fraction, I broke up that 21 as 3 times 7. Then I broke up the x cubed. I broke up the x and y squared on the bottom. And that 14 became a 2 times 7. The only thing separating everything from the rest of the problem is either multiplication or division. Meaning, these 7s cancel out. These x's cancel out. These x's cancel out. And these y's cancel out. The resulting simplified answer is 3x over 2y. Now, like I said, I'm going to show you a shortcut to that in a moment. But I wanted you to see how it actually works. We've done problems like that in the past, but it's always good to get the reminder as to how to do them and what the internal workings of the problem are actually doing. Here's the shortcut to the problem. Again, you don't have to do it that way. Here's a shortcut if one is so inclined. The reason why it's important to know how to do the shortcut is because what if this were like an x to the 11th? If this was an x to the 11th, I don't feel like writing out x 11 times. And I never would. I'm just saying. So if I'm going to do a shortcut, here's what I would think of it as. Okay, number one, everything is separated by multiplication division. 21 over 14, I'm going to simplify like it was a regular fraction. Like it was a regular fraction. Divisible by 7, which means the result would be 3 over 2. Next. How many x's are being multiplied on top? And how many on bottom? If you had to say who would win a battle, the top x's or the bottom x's? The top one. How much would they win by? Just by 1. So you said, now listen to my words carefully. You said the top would win by 1.
To the bottom, you'll have.
What you just said, the bottom will cancel out, yes. Exactly. You said the top would win by 1. How many y's are on top? 1. How many are on bottom? 2. Who wins, top or bottom? By how many? There's your shortcut. That only works in situations like this. That only works in situations like this.
You say situations like this. What situation is that? That, like, they're both divisible by the same.
Well, the lack of addition subtraction. The lack of addition subtraction. For example, I'm actually, you know what? I'll write this one on the board because I'm going to erase it. Check this out. Let's say that this problem were actually the following. You ready? Let's say it was a different problem where it was 21x cubed plus y over 14x squared plus y squared. Okay? Now, it's almost identical, right? Almost identical, but the difference is I put in a couple of plus signs. Nothing cancels. Nothing. I can't actually, believe it or not, this is simplified. There's nothing I can do. There's nothing I can factor. There's nothing I can take out. There's nothing that cancels out. And it's simply because addition, subtraction. Take out a GCF. What would be the GCF at the top?
I was looking at like the 21 x to the third, the 14 x to the second. I would say like 7x squared. But I don't know if that would work.
I can't do it. Because when you're talking about GCF, you're not talking about things separated from the top and the bottom. When you're talking about GCF, it would have to be something like this, where they're in together, attached by addition subtraction. Then you could take out like a GCF like that in this case.
So basically, if there's additional subtraction,
You can't do what you think you can do.
you can't, hold on. I knew what I was gonna say now. Like, with the addition and subtraction, you can't have anything cancel out, but without addition and subtraction, you can't make it easier.
Yeah. That's fair. That's fair. Now, I have one more example to show you before I set you guys off on a few practice problems, but it is going to exemplify this whole addition, subtraction versus multiplication, division argument.
So say the top and the bottom. Do you have a different GCF at the top and a different GCF at the bottom?
If they were separated by addition, subtraction, you know what I'm saying? Like, for example, just weird example. You ready? I'm going to change this one up a little bit. Let's say it was like 21x cubed plus 3. Making it up. 3x, let's just say. Yeah. And on the bottom, it was a 14x squared plus 2x. Okay? Now on the top, I could take out a 3x. And I'm going to do that right here. On the bottom, I could take out a 2x. Okay? Now I'm going to show you something really weird in a moment. But then the x's would cancel. But nothing else would. Right? The x's are actually only separated from the rest of the problem by multiplication division. But nothing else would cancel. I'm going to change one thing. You ready? This is going to really mess with your head. If I change this square to a cube, that would change this to a square. Isn't that messed up? I'm going to exemplify that with the next example. I'm going to exemplify this with the next example. You're going to see. Ha 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 ha. Hee 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 hee. Like a mad scientist. Does it? I'm working with a vocal coach. I can do better. Ready? Hold on. Is that better? No, it wasn't. It was Dr. Horrible. You guys know about Dr. Horrible? You do? Neil Patrick Harris?
Oh my God, Dr. Horrible's like stick-along thing. Oh
Thank you.
I totally forgot that was a thing. I used to love that one.
I have it on Blu-ray.
Of course.
Here we go. Check this out. One more big example before I let you guys try some of this on your own. This is the big example. Now, Paul, for the example that I just put on the board and I erased very quickly, that concept is going to be exemplified here. Now, first of all, the top of the fraction is an x squared minus 4. The bottom of the fraction has two sets of parentheses. I cannot simplify it by canceling out these x's. I can't do it. I'm not allowed. Because those x's are also being separated by subtraction. One's a minus 4 and one's a minus 2. Can't do it. But the first thing that I said, actually, I said two things. I said there are two things that you all have to know about these problems. Number one, how to factor them. And number two, how to know when things cancel out. Those are the two things you need to know. Now, right now, as it stands, nothing cancels out. Nothing. But we can factor. In fact, we can factor the top of this fraction. We can factor that. That is a quadratic. We can factor that quadratic. Well, let's see what happens here. I'm going to do a little side note over here, and I would ask that you do the same thing. Little side note. X squared minus 4. Can you take out a GCF? It's a 1. Can't do it. So a times c. Remember, ax squared plus bx plus c. What is my a times c here? Better question. What's my b value? Ooh. The b? Not here. Remember, I wrote down ax squared plus bx plus c. Technically, I don't have it. Technically, that bx is not there. So what's my b value? It's 0. My b value is 0. Placeholder is a good word. Placeholder is a good word. Like when we did for synthetic division. With synthetic division, I had to have that placeholder. Absolutely 100% yes. So now I ask the question, what is my a times c?
I mean, that's the only thing. Wait, what?
She said -4.
Oh.
Because it would be 1 times -4. Again, we're going to get practice with this. Can you tell me 2 magic numbers that multiply to -4 and add up to 0? 2 numbers that multiply to -4 and add up to 0. -2 and +2. Let's see what happens. -2 and +2. This is my little side note area over here before I can go back to the original problem. This is what I tried to reintroduce to you the other day. Do you remember what goes on top? No.
This is, I'm so bad at simplifying. Like, this is my downfall.
Say again? Oh, what goes on the top? Say it again. Say it louder. The 1x and a 1x. Now, I understand, you're saying, you feel like you're very bad at this stuff, but that's what we're getting practice for. This is what the practice is for.
Like, the second we started doing logarithms, I was like, okay, I can understand this. But, like, this, I don't understand.
I gotcha. We will get the practice with it. When my daughter first learned how to walk, she fell into the cabinet a bunch of times. But now she just falls into it every other day. To be fair, she runs so fast that like her legs
Just like can't.
Yeah, like her body doesn't keep up with the rest of her legs. Like she's just... And then literally at least once a day, do you know what I hear from the other room? Smack. No, not even that. She yells, "I'm okay." She's 3. Anyway, vertically, we get an x minus 2 and an x plus 2. Because nothing simplifies. So check this out. I'm going to rewrite the problem. That was my side note. I have a brand new top of my fraction. I have a brand new top to my fraction.
How though? Like,
Well, do you agree that when things factor, they get broken apart? Do you agree?
this is just like the.
Oh, yes. These are the broken up pieces. Remember, I took that x squared minus 4. This is my little side note. I went through the Tucker method. Again, you probably, if you have alternate methods, you could do this a lot faster. But I went through the Tucker method, and I got x minus 2, x plus 2. These are my broken up pieces. If I were to take these pieces and multiply them back together, exactly. So I took these pieces, and I took that x squared minus 4, and I replaced them. I substituted. They're the pieces. What happened to the bottom of the fraction? Oh, that's what will happen. What did I do? Nothing. They just stayed the same for the time being. Yes. Now, Paul, this goes back to your question from before, the thing that I erased. That happens. The question is why? Think of it this way. don't think of x minus 2 as two separate terms, an x and a negative 2. Don't think of it like that. Think of x minus 2 as some cohesive entity. The top of the fraction has this thing called x minus 2. And the bottom of this fraction has this thing called x minus 2. Tell me, what is separating this x minus 2 from the rest of the problem? Multiplication and division. Isn't that messed up? It's messed up.
Exactly why it makes no sense to my brain.
But I'm just saying, this x minus 2, think of it as a single entity. Look, multiplication and division. It's the only thing separating it from the rest of the problem. Then, this x minus 2 on the bottom. The only thing separating this x minus 2 on the bottom from the rest of the problem is multiplication and division. And believe it or not, well, you're going to have to believe it. This x minus 2 on the top of the fraction cancels out with this x minus 2 on the bottom of the fraction. Because they are exactly the same thing. When you take something and divide it by itself, when you take something and divide it by itself, what is supposed to happen? 1. They cancel each other out. Yeah. X minus 2 divided by itself cancels out, leaving you with x plus 2 over x plus 1. I'll zoom out. There we go. It is an amazing thing. Amazing. I have 3 problems that I want you to try. 3 problems that I want you to try off of that worksheet. Now, I'm going to write the problems on this piece of paper. But for those of you who have the PDF obviously is available through your Google Classroom. Let me flip this thing back. I'm going to have you guys do... oh, that's a good one. Okay. I'm going to have you do numbers 2, 5, oh, goodness. Do I really want to do? Yes, I kind of do. And 10. 2, 5, and 10. Yes, absolutely. I'm going to write them here. So for those of you who don't have access to the PDF, you can see them. And I'll zoom in. But I'm going to have you do 2, 5, and 10. There's 2. There's 5. And there is 10. And I'm going to give you a little block of time to try your best with these 3 problems right here. I'll zoom in. It's numbers 2, 5, and 10. I'll separate them on the board so you can see them a little bit better. Yes?
So when are you allowed to take from top and bottom?
Only when the term itself is separated from the rest of the problem by multiplication or division only. So for example, these 2 R squareds. As of right now, I cannot cancel them out because this R squared is being separated by a minus 4. So sorry, can't do it. 18 divided by 6. Right now, I can't do anything because of that minus sign. Here I could do it because it's only multiplication division. Yeah.
super blurry.
Oh, I'm sorry. It was focused earlier. It'll fix. Oh, come on. Tell you what, once it actually focuses, I'm gonna freeze the screen. There it is. I froze it. Yep, and the camera's still going haywire.
Oh no. No, I'm already confused.
Which one?
5.
Tell me what you tried.
I tried like lengthening it out, and then I tried like. Is there a certain way to work?
Tucker method won't work here only because Tucker method is mainly done for quadratics. You don't have a quadratic here. But first step is always to take out a GCF. Can you what?
Oh, I mean, I guess, yeah, I guess.
Of the bottom?
Well,
What do they both have in common?
I'm throwing things out.
The bottom of that fraction has an Egyptian king in common. I'm hoping somebody gets my joke.
I don't think that's gonna be me, but
It has an Egyptian king in common, the bottom of this fraction. What does it have in common? Somebody tell me, what is the bottom of this fraction? What do both terms have in common? They have 2. So they have a 2.
do I don't get it.
They have a 2 in. I asked you what they had in common. So they have a 2 in common. Say it again. They have a 2 in common. Egyptian king. There you go. Congratulations to those who got it. You heard of King Tut? His full name is Tutankhamun. You know what that's called?
You don't have to tell me if I did, like, what I did wrong, but can you tell me if I did it right? Like, I don't know. I don't know what else to do.
When you take out a greatest common factor, that greatest common factor typically hangs out front.
Is it doing so? Oh, okay. I guess it is hanging out.
It's hanging out front. Now, something may end up happening to it. Remember, like I said, the two things you gotta know. Number one, can it be factored? Of course, factoring
I
it.
don't know.
But you can.
I don't know.
Well, what does GCF stand for?
Okay, then yes.
Yeah, it's a factor. And then number two, can you simplify stuff? That's literally the two things you gotta know. Can you factor it? Can it be simplified?
You said 10 was a hard one. I can't even do 5.
10 is, okay, if I had to put a scale to it, like let's say like 1 being super easy, 10 being incredibly hard, I would say the first two problems would be like, you know, 2s. But then the third one would be more like a 4. It's slightly more difficult, but it's not as difficult as you think.
See, the thing that angers me is once you explain it to me, I'm gonna be like, I kind of knew that. Like, it's tough to think.
It's like a movie that you're
Yeah,
trying to
it's like
figure out how it ends, and you
When
think
you're
you know,
talking,
but
it makes perfect sense, and then when my brain starts talking, it doesn't make sense anymore.
like the Saw movies.
Yes. Essentially.
Wait, did I talk about the Saw movies in this class or the previous class? Oh no, it was the previous class. We're talking about working together and chopping up our butts.
What? Say it.
Nothing. It was the previous class though. We were working on a team activity for escaping this website, where the website was giving like various clues that we had to search the source code for, change like words in the URL, or determine what a binary code would turn into in language, or just random stuff like that. Musical keys that turned into a word. It was very fun. Back to this. All right, I'm going to try this one piece at a time and show you exactly what is expected of you with these problems. Hopefully my camera won't flake out. First problem. This was number 2. 5ab cubed over 25a squared b squared. Now, everything, is it still flaking out?
There you go.
Okay, stay there, camera. Everything is being separated by multiplication division. Everything. So, I can cancel things out the way that I want to because there's no addition subtraction. 5 over 25. Well, I could divide both of those by a 5. 5 over 25, I simplify like it was a regular fraction, and it becomes 1 over 5. With the a's, well, this is really a to the first. You could consider this in one of a couple ways. You could consider it as, come here, you. A to the first over a to the second, if you happen to remember our exponent rules, should technically become a to the negative first, but I'm not allowed to have negative exponents in my answer. And if I'm not allowed to have negative exponents in my answer, do you guys remember that big mathematical word that you're supposed to do to this base in order to get rid of the negative exponent? Starts with an R and ends with an reciprocal. You got it. Yeah, exactly. Now, if you take the reciprocal of this A, it ends up on the bottom of the fraction. That's actually what's supposed to happen. It's supposed to end up on the bottom of the fraction. If you think of it the way that I taught you earlier, one of the A's is on top, 2 of the A's are on bottom. Stuff would cancel, but ultimately the bottom would still have 1A left over. So this would be a to the first right here. And with the b's, you could play that same game where you end up with b to the first right there. Nope. In fact, you could literally just write it like that. It's assumed that even that extra 1 in the front is there. It's kind of nice. I don't know if you had a question or stretching. Cool. Number 5. 18 over 2x minus 6. Now here we can't do the same thing. Can't. We are not allowed to do the same thing that we just did because of that subtraction sign. But I can factor. I factor out a 2. It's my greatest common factor out of the bottom of that fraction. Tell me, what is separating that 18 and that 2? Yeah. Any other operation? Nope. That's all I can do. Mr. Markey, what about the 9 and the 3? Sorry, I can't do it. Why?
You put the 9 on top because 18.
Yes, 18 over 2 simplifies to technically 9 over 1. Yes. And what'd you say? Why can't I do the 9 and the 3? Well, not just because it's a negative 3, but the minus sign. I want to differentiate the idea between minus signs and negative signs because if this problem were actually this, I could simplify it because that's a negative 3. And this would actually become negative 3 over x because the 9 and the 3 would be able to be simplified. So, yeah, that's the main deal right there. Because technically this is a negative 1 times, you know, so I can do it like that. Number 10. I love number 10. I mean, some of you are going to hate number 10, but that's okay. 5r squared over the rest. All right, let me actually, while I'm writing this, let me ask you a separate question. What grade were you in when you first learned about fractions? What grade were you in when you first learned how to add and subtract fractions? Same grade level? Did you say? Okay. What about multiplying fractions? Okay. How does one multiply fractions? Neither. When you say cross multiply, can you be more specific? Yeah, not that. The butterfly method, what you're referring to, that type of cross multiplication is when you are solving an equation where you would, I'm going to put the image up here, where you would go like that and like that. That's not this. Now, sorry, Declan, you said, what did you say before that I said no to? That's when you're dividing fractions, which on this worksheet, look at number 12 right here. Number 12 does have division, which we'll get to. But this problem has multiplication. So I don't have to do anything with the reciprocal. When you multiply fractions, you multiply top times top and bottom by bottom, ultimately getting something like this. Now, I'm going to have to rearrange that junk in a moment. And in fact, I could take a huge shortcut, which I will show you another time. But when you multiply top by top and bottom by bottom, it's basically, well, the numerators times the numerator and the denominator times the denominator. That's what that thing looks like now. But now notice, what's separating the 5 and the 10? Division. What's separating this r squared and r to the 5th? Division. No other operation except multiplication and division. I can still factor. I can still factor the bottom of this fraction. In fact, this fraction, isn't this literally the same thing we did earlier, except we did it with an x? This is like the same problem. Let me factor before I cancel junk out. Let me factor before I cancel junk out. That was that side note that we did earlier. R squared minus 4 is the exact, this is the reason why I gave it to you, so that I didn't have to go through that side note one more time. But now I need you to see this. I need you to see what the heck is going on here. This term known as r plus 2 and this term known as r plus 2 will cancel each other out. This 5 over 10 reduces to a 1 over 2. And who wins the battle of those r's? The bottom by how many? 3. That cancels, and that becomes an r to the 3rd. I have to write my answer clean in a moment. But that is what is going to happen after all of this canceling junk that's going to happen. I could factor the bottom of this quadratic. And then the next question is, does stuff cancel? And yes, it does. A ton of stuff cancels. So let me write this on paper and get to my final answer here. Move that up a bit. First of all, cancel, cancel. Cancel to a 1, cancel to a 2. This just cancels with this. But you said 3 on the bottom still. Holy crap. What is the only term left on top? Yeah. That's all I can do. It's a really messed up thing. But this is what we're going to do. This is partially what we're going to be doing during the course of this chapter. Factoring, seeing if stuff cancels. By the way, you mentioned reciprocal. Obviously, we're going to get to that with dividing. Hey, what do you have to do when you add or subtract fractions? Common denominator. That's going to come back as well. I know, I'm so excited too. Anyway, there's the bell. Half a second off. If you haven't left a comment in the chat, please make sure that you do so. That'd be great. Just punch him.